discuss. Okay, the one is reciprocal lattice vector. Okay, actually reciprocal lattice vector. So suppose we have a unit cell. So say this is my unit cell. Okay, and so this is my x-axis, this is my y-axis, and this is my z-axis. Okay, now if I consider this plane, okay, this plane, so this is your 1 0 0 plane. Okay, and if it is my origin, the distance between origin and this plane is what? The origin between this plane is what? D 1 0 0, isn't it? Okay, now if I want to create a reciprocal lattice, okay, so if I want to create a reciprocal lattice, so say this is my x-axis, this is my y-axis, and this is my z-axis. Okay, so say this is your b vector. Okay, so this is your c parameter, and this is your a, this is your a. Okay, a b c are your lattice parameter of direct lattice. Okay, now this distance is your 1. Okay, 1 0 0, this plane. Okay, so now if I want to calculate a lattice point, okay, corresponding to this point, so what will be the lattice point? Okay, so lattice point will be somewhere here, x-axis. Okay, so because the distance is a, so my lattice point will be what? 2 pi by a, 2 pi by a distance. Okay, so this will be my lattice point. Okay, now 2 pi is what? 2 pi is generally what? Your scaling factor. Okay, so in general, if I have a, okay, so reciprocal lattice, the distance will be 1 by a. So if I take origin and I take the distance, okay, 1 by a, okay, so this will be my reciprocal point. Okay, or you can understand this thing in another way. Suppose I want to calculate the what is the volume, okay, volume of this cube. Okay, so volume of this cube is your height, this distance a, d100 into area. Okay, area, and what is d100? If I calculate d100, so d10 is basically what here, if this abc are equivalent. Okay, so क्या आ जाएगा अगर मैं d100 निकालूं तो 100 is what? h square a square k square b square plus l square upon c square. Okay, if I put 100 value here, this will give me what? 1 by क्या आएगा? d0 क्या आएगा? a आएगा, a. Okay, so if I calculate this 1 by d00, okay, so this will be equal to a upon volume. Okay, and this is equal to 1 by a, this is equal to 1 by a. So area is what? Area is what? Area is your b cross c. Okay, so your area is your b cross c, and volume is what? Volume is your a dot b cross c. Okay, so now this thing equivalent to what? b cross c upon a dot b cross c. ये क्या है? Reciprocal lattice. Okay, this is basically our a dash. Okay, this is what a star. Okay, the lattice parameter of reciprocal lattice. Here only we don't have to give 2 pi. Okay, 2 pi क्यों नहीं दिया? 2 pi तो क्या होता है? 2 pi is a scaling factor. Okay, because ये जो distance होता है, this is an angstrom. Okay, angstrom then 1 angstrom, 2 angstrom. Now if you take 10 to the power 10 above, so if you calculate distance, this will be very huge. ओके तो इतना बड़ा वो कंपेयर टू ये तो छोटा हो गया एंगस्ट्रॉम में, इसका इनवर्स तो बड़ा हो जाएगा. ओके so sometimes, so that's why we scale this dimension. Okay, and 2 pi factor comes because of periodic, because of solution of Schrodinger equation in periodic potentials. Okay, in some book you'll see this will be instead of pi they'll write 1, or they will write some c. Okay, for periodic crystal solids we generally write the constant as the scaling factor as a 2 pi. Okay, generally it is 1. Okay, so this is my what, this is a star. Okay, now similarly if I have a plane at say half of I have a plane 2 0 0 0. Okay, suppose I have a plane now at here. Okay, I have a 2 0 0 plane.
एक्सक्यूज मी सर.
हाँ बोलिए
सर आपने 2 पाई वाली लाइन एक बार फिर से रिपीट कर दीजिए, आपकी आवाज
2
सही
pi
से नहीं आ रही.
2 pi is a scaling factor. Okay, 2 pi is the scaling factor due to solution of Schrodinger equation in periodic potential. Okay, so now this, I suppose this is my 2 0 0 0. Okay, now if I want to calculate what is my d is equal to 2 0 0 0, तो मैं क्या लिख सकता हूँ इसको, I can write simply 1 by 2 0 0 equal to 2 upon d 1 0 0. ऐसा लिख सकते हैं क्या, ऐसा लिख सकते हैं क्या? If d1 0 0 is what, 1 upon h square upon a square plus k square upon b square plus c square, l square upon a square. Okay, so if you calculate 1 0 0 0, so this will come out what, a. Okay, d1 0 0. Okay, if you calculate for 2, so कितना आएगा 2 के लिए कितना आएगा बताइए, a by 2 आएगा. ठीक है, a by 2, so that means 1 by d2 0 is 2 by d1 0 0. Okay, so what I'm trying to say, and this is equal to 2a bar. Okay, similarly I can write, if I want to write 1d 3 0 0 0. Okay, this will be 3 1 d 0 0, this is equal to 3a. Okay, similarly if I want to write 1 d 0 1 d 0 1 0, that will be equal to what, that will be equal to my b star. Okay, 1 d 0 2 0, that will be equals to 2 b bar. Okay, similarly for c I can write, okay, if I have 0 0 1, that is equal to c bar. Okay, so if I want to write instead of d 3 0 0, if I want to write d h 0 0, I can simply multiply this by h a. Okay, similarly here I want to write d h k 0 0, I can simply write here k b star. Okay, similarly if I want to write here d 0 0 l, I can simply write l c bar. Okay, now what is reciprocal lattice vector? Okay, and each of this, okay, each of this distance is a lattice point. Okay, if I want to write a, this one a star, okay, this is a reciprocal lattice point. Okay, this is a reciprocal lattice point corresponding to 1 0 0 plane. Okay, similarly a distance is what, d 1 by d 1 0 0. Similarly this point whose distance is 2 upon d 1 0 0 or d 1 by d 2 2 0 0, this is also a reciprocal lattice point corresponding to plane 2 0 0 0. Similarly I can write for 0 1 0 1 0. Okay, this is a lattice point. Similarly I can write, if this is y axis, okay, I can write for other points. Okay, so each this give me a reciprocal lattice point. Now I told you if it is a DH00, I can write HA. Okay, that means in the reciprocal lattice, okay, I can reach any point by writing my G, this is a reciprocal lattice vector, as a H A K B bar, okay, L C bar. So what I'm trying to say in conclusion कि जो reciprocal lattice vector है उसको we can write in terms of Miller indices. Okay, generally when we write a direct lattice, so when we write a direct lattice we have R equal to what? Na1, okay, Ma2 plus Na3, La3, where Nml they are integers. Okay, so any lattice point can be reached through this position vector. Similarly, in a reciprocal lattice, okay, any point can be reached via this vector. This is reciprocal lattice vector. Okay, and the direction of this vector is always perpendicular to the plane HKL. Okay, direction of this plane is always equal to the perpendicular to this plane HKL, and its magnitude, okay, its magnitude is equal to 1 upon DHKL. Okay, so suppose this is my reciprocal lattice. Okay, its magnitude will be what? 1 by DHKL. Similarly, this is my reciprocal lattice. His magnitude will be 1 by 2 D110. Sorry, this is D2000. Okay, so in conclusion, what I'm trying to say, ये point clear है कि नहीं है जब मैं बोल रहा हूँ कि any point in reciprocal lattice can be written like this. Okay, where HKL, you know the Miller indices are Miller indices. This point is clear or not?
Sir,
Yeah.
can you explain that diagram?
So see, this is my 100 plane. Okay,
Not
distance,
that, sir. Second one.
second one. Okay, so if I want to write this one D, this is D100. Okay, now if I want, so I know, you know, if I have a reciprocal lattice, if distance is A, okay, is reciprocal lattice will be what? Distance 1 by A.
Yes, sir.
Okay, say this is my origin. Okay, now corresponding to this plane, okay, my point will be here, and distance will be what? Inverse of this one.
Yes, sir.
Okay, so similarly, if I give one more plane here, okay, here 200, so the distance is decrease here, but here it will increase. Okay, so this distance is what? This distance is 200. Similarly, I can make one point here, reciprocal lattice, which distance is what? 300. Okay, similarly a point can be there which is DH00.
Okay, thank you, sir.
Same thing in y-axis and z-axis. I can create a three-dimensional reciprocal lattice. Okay, so that means now any point, if I take any point in reciprocal lattice, okay, I can write in terms of G. Okay, where G, H, A star, B star, C star, they are the parameters of your this primitive lattice. Okay.
Okay, sir.
So
Thank you,
H A bar. A bar is what? A bar is equal to 1 by D. Okay, A bar is what? 1 by D100. Okay, and D100 is what? A. So your this is A bar, and this is equal to what? 1 by A. Okay, so if I want to reach here, this is one A bar. Okay, this is what? If it is point, this is one A bar. Okay, so G is equal to what? A bar. Other are 0. 1 A bar, 0 B bar, and 0 C bar. Okay, and A bar is 1 by A. Okay, 1 by A is this interplanar distance. So any point I can write here in terms of reciprocal lattice vectors. Okay, this is the one thing. Okay, now let me write what is the final conclusion. Okay, जिसको आपको याद में रखना है. So the point is reciprocal vector, okay, is in a direction perpendicular to the plane it represents. So in reciprocal lattice, each point represents a plane or family of plane. Okay, so the reciprocal vector is in direction perpendicular to the plane. It represent, and its length is proportional. Its length is proportional. Its length is proportional to the reciprocal. Of interplanar distance. Okay, of interplanar distance. Okay, so I can write the length of a reciprocal lattice vector G is what? 1 upon DHKL. Okay, now it depends, you're taking DHKL or 2 pi HKL. Okay, in solid general will take 2 pi DHKL. Okay, well, that depends how you have written reciprocal lattice. In question, the reciprocal lattice कैसे लिखे है? Any C factor is there or no? If there is a multiplication by 1, you can write 1 by DHKL. If the multiplication by 2 pi, you can write 2 pi. How you define your this reciprocal lattice? Suppose direct lattice is given. Now, when you're writing the reciprocal lattice parameters, you're not multiplying by 2 pi. Then you don't need to multiply by 2 pi here. If you're multiplying 2 pi there, you have to multiply 2 pi here. Okay. So in short, I can write? DHKL is what? DHKL. Okay, DHKL is equal to 2 pi root G. Okay, so this is the interplanar distance. Interplanar distance, and this is what? This is the length of G vector, reciprocal lattice vector, reciprocal lattice vector in, okay, in reciprocal space, or length of the reciprocal vector, okay, in reciprocal lattice, but reciprocal space also, reciprocal lattice space, क्योंकि जो लेंथ होता है वो दैट इज ऑलवेज इन इनवर्स. दिस इज, सो ऐसा नहीं कि जैसे नॉर्मल वेक्टर का निकालते हैं, नॉर्मल वेक्टर का लेंथ कैसे निकालते हैं? नॉर्मल वेक्टर का लेंथ निकालो तो कैसे निकालोगे तुम लोग? h स्क्वायर प्लस k स्क्वायर प्लस l स्क्वायर. ओके, इफ इट इज अ वेक्टर, पर यहाँ पे ijk नहीं है, they are inverse. Okay, so they are inverse of that lattice. So you cannot calculate like this. Okay, so if you want to calculate the length of this G vector, you have to calculate like this: 1 by 1 by the mod of G, or 2 pi of mod of G. Okay, so let me give one problem, then you understand. Shall I erase this one? Can I erase this one?
Yes, sir.
Okay. So let us solve one problem. Okay. We have been given the reciprocal lattice vectors. Okay, b1, okay, equal to 2 pi by a, okay, x1, b2, be given 2 pi a yk, okay, and b3 I have been given 2 pi by a z cap. These are reciprocal lattice vectors. Okay, now I want to calculate the length of what? Length of reciprocal lattice vector. Okay, so this is a simple cubic. Okay, reciprocal lattice of simple cubic. Okay, so how can I write now the length of, say, the plane is given to me, say, what is the question? The plane is 1 0 0 0. Just let me check the question. कौन सा plane दे रखा है? 2 1 0 1 1 0. Okay, or you take plane as a 1 1 0. Okay, say the plane is given 1 1 0. Okay, 1 1 0. Now calculate the length of reciprocal vectors corresponding to this plane. Okay, calculate length of reciprocal lattice vector corresponding to this plane. Okay, so if I want to calculate, so d will be what? If I want to calculate d, okay, so d will be what? D110. It will simply a by root 2. होगा नहीं होगा? And if I want to do this calculation in my reciprocal space, so reciprocal space में मेरा g क्या हो जाएगा? g is h a bar, h k b bar, and h k l c bar. Okay, now my plane is 110, so I can write my reciprocal vector as a cap, okay, and b cap is 0 हो जाएगा. Now what is a cap? A cap for simple cubic, that is 2 pi by a, okay, 2 pi by a x cap. And what is b? So they are given simple cubic, okay, so b star is also okay. They are given a1 b1, okay, so I'm writing this x1, so this is b1, okay. Now their notation is changed, b2, and this is b3. Okay, so if I want to write b1, so b1 is what? 2 pi by a x cap. B2 is what? 2 pi by a y cap. Okay, so we put the value here. This will give me 2 pi by a x cap plus y cap. Now if I want to calculate the length of this vector, okay, so length of this vector will be what? Length of g. Okay, say this is L equal to L, so length of the g will be equal to what? 2 pi by magnitude of g. Okay, now what is the magnitude of g? Magnitude of g is under root, okay, 2 pi by a square, okay, plus 2 pi by a square. So this will give me what? 2 root 2 pi by a. Okay, now if I write here the length will be 2 pi by g. This will be root 2 pi by a. Okay, pi cancel, 2 cancel, this become a by root 2. So this is the length a by root 2. Here also you get a by root 2. So this is the same, na? Interplanar distance should be equal to your length of g in reciprocal space. Okay. ये point clear है? What the definition what I'm trying to give? Okay. The length of this reciprocal letter vector is equal to the interplanar distance. This is the one thing. Okay.
सर ये मैग्नीट्यूड ऑफ जी जो है ये हम 2 पाई अपॉन नीचे क्यों कर रहे हैं जबकि हमें वही फाइंड करना है. आपके जो लेंथ ऑफ जी वेक्टर है वो हम एल क्यों ले रहे हैं? वो मतलब मैग्नीट्यूड ही तो हुआ जी का जो हमें फाइंड करना है.
तो लिखने के लिए लिख रहा हूं ना, क्या लिखेंगे? यू जस्ट राइट लेंथ. इफ यू वांट टू राइट वन वर्ड, लेंथ ऑफ जी से इक्वल टू, मुझे लेंथ चाहिए, इसको वर्ड में लिखेंगे कैसे? क्या लिख रहा हूं मैं?
ओके सर,
लेंथ ना. ओके, सो लेंथ इज 2 पाई बाय जी. ओके, क्योंकि वो इनवर्स होता है ना, इसमें रेसिप्रोकल इनवर्स होता है ना. अगर वैसे होता तो लेंथ ऑफ जी करके इक्वल टू कर देता मैं डायरेक्ट लेटर्स में, तो इसमें तो इनवर्स होता है ना. तो वी हैव टू फाइंड इट मॉड, ओके, हियर, एंड देन वी टू मेक इनवर्स ऑफ दैट वन. दैट्स व्हाई आई एम राइटिंग दिस वन दिस वे, एल, टू डिफरेंशिएट. क्लियर? So this is reciprocal, your reciprocal vector. Okay, now let me plot the evolved construction, evolved sphere. Okay, evolved sphere or geometrical interpretation of Bragg's law. Now, what do you mean by evolved sphere? Okay, so suppose I have a reciprocal lattice. Okay. So this is my reciprocal lattice. So how to show Bragg condition graphically, okay, or geometrically? So this is my reciprocal lattice. Okay, this is my reciprocal lattice. Now, in X-ray diffraction, that is the elastic technique. Okay, so the scattering is elastic. Okay, in X-ray diffraction, okay, the scattering is elastic. Scattering is elastic. Scattering is elastic means क्या होता है कि आपका जो इंसिडेंट वेव है उसकी एनर्जी में लॉस नहीं होगा. ओके, अगर इंसिडेंट वेव की वेवलेंथ लैम्बडा है, इंसिडेंट, ओके, इफ इंसिडेंट वेवलेंथ is lambda, then scattered wavelength will be also lambda. Scattered wavelength, that will be also, that will not change, that will be also lambda, because lambda is related to energy will not change, so only the direction will change. Okay, now suppose I am in that crystal, I am incidencing a X-ray, a monochromatic X-ray of wavelength lambda. Okay, and I'm getting, and I have the reciprocal lattice of this diode lattice also. So what I can do, I can consider any point as an origin. Okay, and I can plot a sphere of radius 1 by lambda radius. Okay, so if this is my reciprocal lattice, okay, I'm taking this is the origin. Okay, see, this is my origin and this is the wave vector, and this is the distance or length of 1 by lambda magnitude, and I am plotting a sphere. Okay, and suppose here there is here it may be a lattice point, there not be a lattice point. Okay, so this is the distance. Okay, so this, say this is distance is my, this is my O. Okay, say this distance is B. Okay, and say this distance is A. Say this point is A. Now this sphere is touching this point. Okay, so this point is what reciprocal. This is my origin and this is a lattice point. Okay, so I can always write a G vector here. Okay, so forget that one. Now I am putting a perpendicular here. So this angle is theta. This angle is also theta. Okay, now what is the OB equals to? OB किसके equal है? This is 1 by lambda. Okay, this is my incident wave and this is my scattered wave. Okay, scattered wave also have the magnitude same 1 by lambda, length is also same because the intensity will not change. Okay, so this is the incidence is actually more here, but I'm taking opposite just to plot a sphere. Okay, so this is a vector of 1 by length, this is incident and this is scattered. Okay, that also have a length 1 by 1, this length 1 by lambda. Okay, now if I want to get OB, so OB कितना हो जाएगा बताओ?
√2 by lambda.
√2 कहाँ से आएगा? ये आपका hypotenuse है. Okay, this become your base, this become perpendicular. So if I want this distance कितना हो जाएगा आपके पास? बताओ, ये कितना हो जाएगा आपके पास? sin theta?
OB is hypotenuse. OB is hypotenuse.
हाँ बताइए
सर. ये 90 डिग्री नहीं बनेगा सर?
90 डिग्री बनेगा ना, परपेंडिकुलर 90 डिग्री तो है.
तो सर ये पूरा ए वाला एंगल,
तो हाँ, कौन सा वाला?
ए वाला एंगल ए,
वो 90 थोड़ी है.
सर.
ठीक है, वो तो कुछ भी हो सकता है ना, कोई पॉइंट तो कहीं भी, यहाँ पॉइंट ये भी हो सकता है, यहाँ पे टच कर सकता है, कहीं भी टच कर सकता है. ओके, सो अभी मुझे ये डिस्टेंस चाहिए. ओके, ये बीच में ले लो, ओसी ले लो. हाँ, तो ओसी कितना हो जाएगा बताओ? 1 by lambda. साइन थीटा क्या होता है? साइन थीटा क्या होता है? Sin theta will be what here? OC upon 1 by lambda. Okay, so OC will be what? Okay, you are 1 by lambda sin theta. ये आएगा क्या? So this is OC. Similarly, here also I can write same thing, BC. Okay, so this will be what here? 2 by lambda sin theta. Okay.
Drop the figures now.
मैं figure नहीं दे पा रहा हूँ अभी. And what is this distance OB? This is what? 1 by DHKL. If this plane is HKL, distance is what? DHKL. So DHKL equals to what? 2D lambda sin theta. So if I write here, this will be 2DHKL equal to what? 2D sin theta. Is there any mistake here? Let me check. 2D sin theta ऊपर आना चाहिए ना. So there's a mistake here writing this triangle. ये बताओ क्या कैसे लिखेंगे? इस triangle को कैसे लिखेंगे? इस distance को क्या लिखेंगे? Okay. So sin theta equal to this is perpendicular. Okay. So perpendicular will be OC. Okay, OC, and this will be length will be 1 by lambda. Okay, that is sin theta by lambda. Okay, so this will be 2 sin theta by lambda. 2 sin theta by lambda, not this one. Okay, this will be your 2 sin theta by lambda. Okay, so that will give me 2 DHKL sin theta, okay, equals to lambda. And this is what? This is your Bragg condition, Bragg's law. So this is a geometrical interpretation of Bragg's law. ओके, तो ब्लैक्स लॉ बेसिकली क्या बता रहा है? ज्योमेट्रिक इंटरप्रिटेशन का मतलब क्या है? ज्योमेट्रिक इंटरप्रिटेशन का मतलब ये है कि इफ यू हैव अ रेसिप्रोकल लैटिस and you know the energy of your X-ray beam and you plot a sphere of 1 by lambda, that is called Ewald sphere. So wherever that Ewald sphere will touch any lattice point, that will be your diffraction peak. जहां पर ये आपका Ewald sphere किसी पॉइंट को टच करेगा, उसके करस्पॉन्डिंग आपको एक्सरे में डिफ्रैक्शन मिलेगा. इज दिस पॉइंट इज क्लियर? जब हम ये कंडीशन सेटिस्फाई होती है, then you get the a diffraction peak, or you get diffraction condition satisfied. So that means you get a peak in X-ray diffraction. Similarly, if you have a reciprocal lattice and if you draw a sphere of 1 by lambda length, okay, then if you're touching some lattice point, okay, that means for that plane X-ray diffraction condition will be satisfied. Is this definition clear? Interview में पूछते हैं what is Ewald sphere. So Ewald sphere is nothing. If you plot a sphere of 1 by lambda radius in reciprocal lattice, okay, so Ewald sphere is basically geometrical representation of a Bragg law. So when you plot a sphere of 1 by length in reciprocal space, wherever my Ewald sphere is touching any lattice point, for that particular lattice point, which represent the family of planes HK, any point in reciprocal lattice is represent a plane. Okay, so that means for that particular plane, your diffraction condition will be satisfied. Okay, I hope I'm clear. Okay, so can I erase this one now? Shall I erase this one? Okay. So your Ewald sphere is what? Geometrical representation of your X-ray condition, X-ray diffraction. Okay. Now let me write the vector form of Bragg's law. Bragg's law. Okay. So suppose you have this lattice point. Okay, just now I have drawn. I should have erased. Okay, this is my lattice point. Okay, this is my lattice points. Now I have drawn a sphere. Okay, which is touching some point. Okay, more than one point also it can touch. Okay, now I told you that this is my incident X-rays. Okay, so I'm now representing it by K. Okay, and this point, this is my refracted X-ray, diffracted X-ray. Say this is wave vector is K dash. Okay, and this is my what? This is my origin in reciprocal lattice. So this will be what? My G vector. Okay, so this is K vector, this is K dash vector. Okay, this is my incident wave. Okay, this is my diffracted wave. Okay, now since the scattering is elastic, so the magnitude of K dash is equal to magnitude of K. Okay, where K is equal to what? 2 pi by lambda. अब दोनों का lambda बराबर है तो K dash equal to K. Okay, now if I write, so this is my reciprocal lattice vector. Now if I apply this thing, so I can simply write my K dash vector is what? Equal to K plus G in this triangle. Okay, and now if I take the square of this one, so K plus G का square. Okay, now vector का square equal to its mod square. Okay, so this will be what? K square plus G square plus 2 kg. Okay, now K and K dash are equal. Okay, so this will cancel out, K dash and K. Okay, so I will be remaining with what? I will be remaining 2 K dot G plus G vector का mod का square equals to 0. Okay, so this is also your vector form of Bragg law. Okay, this is the vector form or Bragg condition in reciprocal space. Okay, reciprocal lattice or vector form of your Bragg law, whatever you want to say. Sometimes they ask directly this question. Okay,
So one more statement you said reciprocal lattice of.
what is it?
So you said now vector form of Bragg law or reciprocal lattice.
Or the Bragg condition in reciprocal lattice. Okay, Bragg condition in reciprocal lattice. Okay, so I'm erasing this one. हाँ बोलिए.
सर ये वेक्टर फॉर्म कैसे इक्वेशन है सर?
अभी निकाला ना भी हमने भी ये ज्योमेट्री है. ओके, ये इंसिडेंट का वेव वेक्टर है, इसका वेक्टर है. ओके, और मैंने बताया कि लैटिस रेसिप्रोकल लैटिस में एनी डिस्टेंस फ्रॉम ओरिजिन टू दिस इज इक्वल टू रेसिप्रोकल लैटिस वेक्टर जी. ओके,
तो सर these things I am understanding sir.
हाँ.
I just want to ask कि मतलब ये वेक्टर आपने जो we have made, so how to write this equation by this vector?
तो वेक्टर में तो ये इक्वेशन वेक्टर फॉर्म में तो लिखी हुई है, के जी वेक्टर फॉर्म में लिखी हुई है. ओके,
सर,
तो इस चीज को वेक्टर फॉर्म बोल रहे हैं. अब इसको जनरली यूज करते हैं व्हेन यू आर कैलकुलेटिंग बिलियन जॉन्स. ओके, वो कल डिस्कस करेंगे हम लोग इसको. ठीक है, सो आई एम इरेजिंग दिस वन. ओके, अभी हमारा चैप्टर खत्म हो गया है. एंड बिलियन जॉन आल्सो मैंने आपको बता दिया है कि बिलियन जॉन क्या होता है. जो प्रिमिटिव यूनिट सेल होती है दैट इज कॉल्ड योर बिलियन जॉन. प्रिमिटिव सेल का जो फर्स्ट एरिया होता है दैट इज इक्वल टू एरिया ऑफ बिलियन जॉन. ओके, तो कल थोड़ा सा बस दिखा देंगे कि कैसे ड्रॉ करते हैं. सो आई एम जस्ट गिविंग सम होमवर्क बिकॉज हमारा एग्जाम है, तो एक दो प्रॉब्लम ट्राई करो इसका. सो द क्वेश्चन वन इज the Bragg angle for reflection from the planes. Okay, so we have given a plane for which h cut square k square l square equal to given 8. We are given for a plane, so the Bragg angle is given, theta is given 20.2 angstrom. Okay, and the wavelength of X-ray is given as a 1.54 angstrom. Okay, so the Bragg angle for reflection from the planes for which this condition is satisfied, planes for which this condition is satisfied, is given, angle is given, lambda is given. Okay, you're asking find the lattice constant. Find the lattice constant. Find the lattice constant. Okay, and indices of the reflection. Indices of the reflection. ओके तो ये कौन से प्लेन के लिए होता है? एच स्क्वायर के स्क्वायर एल स्क्वायर इक्वल टू 8. कौन से प्लेन के लिए होगा ये कंडीशन कौन से प्लेन के लिए सेटिस्फाई होगी? एच के एल की वैल्यू क्या लिखूं कि 8 आ जाए? कौन से प्लेन के लिए? 2 2 वेरी गुड. ओके सो दिस प्लेन इज व्हाट 2 2 0. और किसी के लिए सेटिस्फाई होगी नहीं तो प्लेन आपको पता चल गया 2 2 2 0 है. Okay, you have been given theta, you have been given lambda, you can easily find out what is the lattice constant. Okay, so this is the one problem you have to solve. Okay, then one more
Sir,
problem.
how we have 2 to 0 plane, sir?
So this is HKL na? HKL. So he's saying the planes for which this condition is satisfied. So only this plane, this condition satisfies. Okay, you can write anything 1 1 1 1 1 0 1 4 4 yeah or 1 4 1, anything you write, only for this plane this condition will satisfied. That means your plane is 2 to 0.
Okay, thank you, sir.
Okay, now a two-dimensional lattice is given. Two-dimensional lattice is given. Two-dimensional lattice is given. Okay, for that they are given a equals to 1.24 I and they given b equals to angstrom. Okay, and they given b equals to 2.44 angstrom, and the angle between a and b, okay, gamma, they given 120 degree. Okay, so they are asking construct the reciprocal space. Construct the reciprocal lattice. Construct the reciprocal lattice means what? You have to calculate a star and b star. So AB magnitude is given and the angle between these two vectors is given. Okay, so these two questions. Okay, I'm giving one more question. All three questions you have to do and you have to send me today. Okay, क्वेश्चन क्लियर है ना? ये क्या पूछ रहा हूं मैं? जो ए और बी दे रखा है उनके बीच एंगल दे रखा है 120 डिग्री, तो पूछ रहा है कि आपका रेसिप्रोकल लैटिस कंस्ट्रक्ट करो.
सर फर्स्ट क्वेश्चन में 202 या 2
कोई भी ले लो आप, कोई भी ले लो आप, कोई भी ले लो, कोई भी ले लो. Okay, now again you have given a honeycomb lattice. You have been given a honeycomb lattice. Okay, and you have been given this vector a. Okay, so this is your a2 and this is your a1, that is given, and this is your distance a. Okay, now it says if the lattice spacing a equal to 1, which is lattice spacing a equal to 1, okay, and this is your y direction, this is your x direction, this is your x, this is your y direction is given. Okay, if the lattice spacing is 1, okay, then the reciprocal lattice vectors are, calculate a reciprocal lattice vector you have to calculate. Okay, the answer is, okay, so if the answer is coming, suppose 4x cap plus 3y cap, you can write as a 4 3, or is coming 4x cap, you can write 4 0. इस फॉर्म में इनको आंसर देना मुझे.
Sir, can you repeat the question once more?
So you have this lattice, okay, for which the primitive vectors are a1 a2, lattice spacing is a. Okay, now you have to calculate the reciprocal lattice vector. Reciprocal lattice vector means what? You have to calculate this A star and B star. Primitive lattice vectors. Question clear hai? You have been given this lattice, okay?
Yes, sir.
Direct lattice A1, A2 is given, okay? And you have to find out this A star, B star, and only A is equal to 1. ऐसा question तुमने बहुत बार किया है, 2-3 बार किया है, but only now magnitude is A is equal to 1. Other things are same. Okay, so I'm stopping here. Any doubt from today's class? Okay, so I'm stopping here. Okay, meet tomorrow. आपका एक्सेल डिफरेंशियल खत्म हो चुका है, but I will start new thing from only after your exam. That means on Saturday. Okay, so tomorrow if there is class, we'll do the same thing only. Okay, because I don't want to start new chapter now.
So new thing मतलब which chapter?
चैप्टर उसके बाद हम करेंगे या तो डायलेक्ट्रिक स्टार्ट करेंगे, ओके, डायलेक्ट्रिक सुपरकंडक्टिविटी बाकी है वो करेंगे, या फिर थर्मल प्रॉपर्टीज देखते हैं कौन सा शुरू करते हैं, सैटरडे को देखते हैं।
एग्जाम के लिए इतना ही आएगा?
हाँ, एग्जाम के लिए तो पूरा एक्सेप्टेशन करा दिया ना मैंने आपको, रेसिप्रोकल लैटिस पूरा कराई दिया मैंने आपको, पूरा रेसिप्रोकल लैटिस बता ही दिया है, एक्सेप्ट डिफ्रैक्शन में पैकिंग फ्रैक्शन वगैरह सब बता ही दिया है आपको मैंने। ओके, एक्सेप्ट डिफ्रैक्शन में तो यही कोर्स है आपका, और जो मिसिंग प्लेन्स था उसी पे क्वेश्चन आते हैं, मिसिंग प्लेन्स कौन सी इंटेंसिटी मिसिंग है, फिर वो बिलियन जोन का एरिया निकालना आता है, तो जो परमिटेड लैटिस का एरिया होता है वो भी हमने कल एक क्वेश्चन करा था, उसका भी हमने। ओके
सर एक डाउट था।
हाँ पूछिए।
सर जो आपने इवाल्ड स्फीयर के लिए कहा कि जब हम रेसिप्रोकल लैटिस में ही स्फीयर बनाएंगे और जो पॉइंट टच करेगा स्फीयर को वो सेटिस्फाई करेगा डिफ्रैक्शन कंडीशन, तो वो पॉइंट के लिए या उस पूरे प्लेन के लिए जिसमें वो पॉइंट लाई कर रहा है?
वो पॉइंट है, मतलब वो पॉइंट इज रिप्रेजेंटिंग बेसिकली ये प्लेन ना, in reciprocal lattice each point is corresponding to the a family of planes. Okay, or you just one plane. Okay, so that means for the point which is corresponding to particular plane, for that plane the axial diffraction condition will get satisfied.
Okay sir.
Okay, so I'm leaving. Thank you very much.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.